Let's get familiarized with the unit operations that we're going to encounter in a petroleum refinery. And make no worries, this is just to get familiarized with these processes. Eventually, we're going to see further on the unit operations and in the processes on the respective process. For instance, we have a section dedicated to distillation. We're going to see crude distillation unit, CDU, and vacuum distillation unit, VDU. Essentially, these are the only two distillation units that separate roughly petroleum or crude oil. Then we have thermal cracker, which has piece breaking, cokers, and so on. Hydrotreaters essentially remove hydrogen sulfide. Fluidized catalytic cracker, the famous FCC. Naphtha splitter, which sends naphtha into gasoline, naphtha into light naphtha, and naphtha into naphtha that's going to be used in the steam cracking process. Dereformer, or catalytic reformer, alkylation and isomerization units. We have byproducts which are going to be treated in the gas treating units, and of course blending pools. What's a blending pool is nothing more than a storage tank which accepts several products, then blend them in order to achieve final specifications of the product. And I want to show you several types of processes found in this refinery: separation processes, conversion processes, finishing processes, and environmental processes. Those are the main processes that you're going to encounter in petroleum refinery. Separation processes, as you can imagine, are based mostly on mass transfer separations, such as distillation and absorption, extraction, crystallization, and even adsorption. Then we get primary distillation, the most important one, which is the atmospheric, separates roughly into refinery gases, LPG, gasoline, naphthas, kerosene, jet fuel, diesel oil, and heavy industrial fuels, and as well as the typical atmospheric residue or residues. These residues go to this vacuum distillation, which is the secondary distillation. And here we're going to produce light distillate, middle distillates, heavy distillates, and further residue is going to be converted into asphalts, bitumen, waxes, and so on. Then we have conversion processes in which kinetics and reactions are going to be happening here. So we have several processes such as catalytic reforming. Reforming is nothing more than increasing the aromatic content. Isomerization is favoring isomers that increase the octane rating, and alkylation increases the chain number of carbons. So this plus this is going to give us something like that. This is converted to this maybe, and catalytic reformer is something like this, converts into something like this. Okay. Thermal processes such as piece breaking and coking. What we're doing here is converting low value residues into interesting high energy content materials that can be used in later applications. And many catalytic processes. What we're going to encounter are many catalysts that are used in this industry. For instance, FCC has a specific set of catalysts. In hydrocracking, we use other type of catalysts, steam reforming, hydroconversion, and so on. Then finishing processes are the final types of processes that you need to do in order to ensure that these are going to be usable materials. For instance, hydrotreatment, removing of hydrogen sulfide or sulfur via hydrogen sulfide. Hydrogenation, probably you're wondering why are we hydrogenating material. For instance, acetylene will be converted to ethylene because ethylene can be converted later on into a polymer known as polyethylene. Sweetening, what's this? Essentially converting sour materials into sweet materials, most likely natural gas and other gases, liquefied petroleum gases, and so on. Finally, environmental processes such as acid gas processing, the name implies treats acid gases. Stack gas processing, many stack gases contain CO, CO2, and so on. Those will be cleaned up in order to avoid contamination or pollution of the air, and wastewater treatment processes as well. We're going to be treating water, maybe because they are alkaline, meaning high pH values, maybe because they are acidic, low pH values, maybe because they have metallic content, heavy material, and so on. So these are the four main processes that we're going to encounter, and these are the main unit operations that we're going to see in a petroleum refinery.